The first alert didn't come from security. It came from billing. Unusual spike in outbound traffic costs. At 0137, then PagerDuty fired. Egress traffic anomaly detected in production cluster. Slack followed almost immediately. Why is one service sending traffic to unknown IPs? Seeing sustained outbound connections from internal namespace. Is this expected? I opened Grafana. Network egress had doubled, then tripled. One service stood out. Not high CPU, not high memory, just talking, constantly, to somewhere we didn't recognize. And it wasn't failing. It was succeeding. That's what made it worse. We were running on AWS, EKS cluster in US East 1 with strict network segmentation, service mesh using Istio. All service-to-service communication was MTLS enforced, zero trust model across the board. Every service had identity, every request was authenticated and authorized. Outbound traffic was restricted through egress gateways. Nothing talked to the internet directly, or at least that was the policy. We had around 80 microservices. Traffic peaked at about 2K requests per second. Databases were a mix of RDS PostgreSQL and DynamoDB. CI/CD was GitHub Actions pushing to ECR and Argo CD handling deployments. Monitoring stack included Prometheus, Grafana, Loki, and VPC flow logs. From a design perspective, it was locked down. Very little room for anything unexpected. Every log fed into a centralized security dashboard. No user complaints, no latency spikes, no error rate increase. Everything customer-facing looked normal. But internally, something was off. Outbound traffic from a single service was continuously increasing. It wasn't bursty, it was steady, almost like a stream. Destination IPs were external, not part of our known allow list. Flow logs confirmed it, persistent connections to multiple endpoints. At the same time, request volume to that service had not increased, which meant this traffic wasn't driven by user activity. It was doing something on its own, and whatever it was doing, it was allowed. First thought was misconfigured job, maybe a background worker pulling data from an external API. We checked recent deployments, nothing new, no config changes. We checked logs for that service. It was a reporting service, used for generating analytics dashboards. Logs showed normal internal requests, nothing about external calls. That didn't match the network data. So we jumped into the pod, ran netstat, active outbound connections, multiple. We traced one. It resolved to a public cloud storage endpoint, not ours. Now it started to feel serious. Security joined the call. We checked IAM roles. No unusual permissions. We checked container image. Same digest as previous deploy. We checked environment variables, nothing suspicious. Then we looked at the service mesh. Istio policies showed strict MTLS between services. But outbound traffic policies, there was a gap. This service was not routed through the egress gateway. It had a direct outbound path. That shouldn't happen. We reviewed the namespace configuration. Most namespaces had a default deny policy, except one. This one. It was marked as legacy, exempted from strict egress controls. That was the first real clue. Meanwhile, finance escalated. Outbound bandwidth costs increasing rapidly. We need to stop this. We had to decide, kill the service and risk breaking dashboards, or isolate it and investigate further. We chose isolation, applied a temporary network policy blocking all outbound traffic. Within seconds, egress dropped. But then, errors started appearing. Internal dashboards failed to load. Users began reporting issues. We had broken it. We needed a controlled fix. We pulled a full trace of the service behavior. With outbound blocked, logs became more revealing. The service was attempting to upload data, large payloads, serialized reports. We traced the code path. There was a feature, export reports to external storage. It was originally built for a single enterprise client, behind a feature flag, disabled by default, but enabled in this environment. The endpoint URL was set, pointing to a third-party storage service. And then, the authentication. We found an API token, hard-coded in the config map. Legacy setup, no expiry, no rotation. The reason it bypassed controls was historical. Before we enforced strict egress, this service was whitelisted, and it was never brought back under policy, zero trust, except for one service. First step was to stop the data flow. We removed the outbound exemption, forced all traffic through the egress gateway, which immediately blocked unauthorized destinations. Then we disabled the feature flag. We revoked the API token and migrated it into Secrets Manager with proper rotation. We updated Istio policies, no namespace exemptions. Every service must go through the same controls. We validated by testing outbound calls. Only approved endpoints were reachable. We monitored egress metrics. They stabilized within minutes. What failed was consistency. We had a strong zero trust model, but it was not uniformly applied. One legacy exception created a blind spot. Detection was also reactive. We noticed traffic volume. not policy violations. We had no alert for services bypassing egress controls. Observability showed symptoms, but not enforcement gaps. Zero trust only works if it is absolute. Exceptions become entry points. Egress control is as critical as ingress. Outbound traffic should be treated with the same scrutiny. Legacy configurations must be audited continuously. Secrets should never live in config maps. In the end, security is about consistency in every layer.